the surface of the moon for that 6 months. And then you board Orion to get back home. That's what we're building now. Now, one of the things I love about the space industry is that I get to work with incredible dreamers who turn their dreams into reality. And one of the things I love about working in the augmented and mixed reality industry is that you get to work with incredible dreamers who turn their dreams into reality. It's a fun space right now. It's amazing things are taking place. But it's not always perfect. This is how we think that it works. We think that we take a lot of smart people, we put them in a room, we think, we plan, we brainstorm, we draw on whiteboards, and we come up with a solution, right? And then it leads to this perfect environment where everything is happy and it works perfectly. Okay, I see some people kind of laughing, and I know exactly what you're thinking. How many people in the room are using AR in their enterprise now? Okay. How many people are thinking about using AR in their enterprise, and you're here to explore? Okay. Very interesting. Just so you know, it doesn't always work like this. Sometimes there are moments that work like this. Sometimes there are moments that are adventures, but that's okay, because we see not problems, but challenges, and the challenges make it fun. It keeps it interesting. Actually, I want to ask one more question. For those who are using augmented reality in your industry, who has had it work this way? Okay, for those of you who are new, take a look around the room. There are no hands, I don't think. Any hands? Okay. So from time to time, things will look like this. If you have a strategy, if you don't have a strategy, there are times where it will be an adventure. These are the times where you figure out how to fly, right? So that you don't have to navigate the scenario that looks like this. So there's different forms of strategies that you can take. You can work through the process as it exists today. We can navigate around it, or you can punch through it. When we get into talking to details around strategy, it gets much more detailed. But this is just 3 ways of thinking through the scenarios that you see. And I'll show you a few examples. The first one is pretty straightforward. You're navigating the path. We do this quite often with many of our AR use cases across Lockheed. You're following the path. This is one of my favorites. So this is the Orion spacecraft. And how many people have been to a launch? All right, it's amazing. What did you notice about the sound? You can be several miles away, and you can still feel the sound. It's incredible. But we have to put the spacecraft through that same test in that acoustic environment. So we do. And it's like the engineers remind me. I'm a mathematician. The engineers at Lockheed remind me that engineering is just math, but louder. In this case, it's very loud. We put these stacks of speakers around the spacecraft, and we blast it with acoustic. This is just a cutaway. It actually surrounds the entire spacecraft. Now, to do this, they usually move the spacecraft into place, and then they have microphones mounted to the spacecraft on booms. It takes a long time to set up, and we have to be very cautious working with the spacecraft in this environment. Now, if we use augmented reality, and if we attach the booms to other objects instead of the spacecraft, we can set it up in advance. So it changes the critical path of the spacecraft. We can have it all set up in advance, but we need to see where the spacecraft is. It's very dependent upon positional alignment. So this is one area where AR helps us understand what the environment looks like and place the microphones accurately before we run the test, and actually before we run to move Orion into that environment. I'll show you another picture that's a fun one. So this gives a new meaning to surround sound. You notice the people up in the top right corner. That gives some context to how tall these speakers are. Okay. Now, another approach is to bypass the maze, to work around it. I'll show you an example of what I mean here. For us in the defense industry, sometimes we have a challenge with using wireless technology. So imagine trying to take something like AR or AR devices into an environment that doesn't allow Wi-Fi or Bluetooth or wireless sources. It can be a real challenge. So we approach the leads and we say, well, what if we don't use wireless or Bluetooth, but we can still run wireless within the environment? They say, no RF. Okay, imagine we don't use Wi-Fi or Bluetooth or RF. And we have the idea. We even know that it works. We've tried it, we've tested it. The solution is light. So this is Harold Haas back in 2011 at a TED Talk. He took a lamp, a normal lamp, with a normal light bulb, and he put a modulator on it. And then he has a sensor below. And what he's doing is he's streaming HD data, HD movies, across through light in place of Wi-Fi. Now, this works. This was back in 2011. The way that it works today is you take a dongle, you plug it into a USB-C port. You're receiving data over visible light. You're taking infrared data and streaming it back to the transceiver. Let me show you this. So you can also network across a room with mini lights. Instead of the cone of silence, think of cone of data. If you're outside of the cone, you don't receive data. If you're inside the cone, you do. There's secure features to this, but there's another advantage to it that I think is beneficial regardless of whether you work in the defense industry or not. It's fast. It's really, really fast. So right now we have gigabit rates with a dongle that plugs into the USB-C port. In test environments, they've seen 224 gigabit per second rates. Now that's like streaming 50 HD movies per second in context. It's really fast. So what this means is that wireless is no longer the weak link to data. This one's exciting to us. I think that as we work in VR and AR spaces, we'll need to be able to accomplish faster rates. This is possibly a technology that could help us in this industry. Now, the third one is the one to just punch through the walls, break down the path. Here's an example that we had, it was a little over a year ago. These are spacecraft adapter jettison panels. They protect portions of the spacecraft as it travels through the atmosphere, and then they're jettisoned away. Part of the manufacturing activity for this takes place in Michoud, down near New Orleans. So our task seemed pretty simple on the surface. It was to place fasteners that adhere to the surface, to mark the location of these fasteners across this tall panel that would later run cable harnessing through. So pretty simple. There's 309 fasteners that we need to place across the surface. But we need to place them with half-inch accuracy. And when we looked at the environment, they said it can't be done. The floor is shiny, the walls are too far out, we're in a high bay, the ceilings are really tall. The composite is a composite that depth sensors do not recognize. It has a black body effect. So when you look at the panel through a device, it's as if it sees through the panel. It doesn't recognize that the surface is there. So I said it can't be done. You can't align. If you are somehow able to align, you'll have several inch accuracy at best. And then there were other challenges. They said, these panels are flexible. And in real life, the panel doesn't sit in the same geometry that we find in the CAD model. It's more flexed. So even if you could align, you're going to have difficulty with this because it's not in the same geometry as the model, and you're overlaying model content onto the panel. So we went back to the drawing board, and actually we went to the drawing board within about 2 hours that morning, and came back and were able to align and place all of the fastener locations within 0.1 inch tolerance, which was well within the half-inch tolerance that we had as a requirement. For this one, you'll see across the industry, you'll have some skeptics who say things can't be done. And that's where you go back to the dreamers who dream, who make things real. We see this over and over where it seems like it will not work, but if you think creatively, you can do it. In this case, we aligned to inserts in each section of the panel that were at much more accurate tolerance level than the fasteners, and it worked just fine. When we talk about fasteners, here's what we see. So this one on the left is the first case that I just talked about. In addition to being able to hit 0.1 inch tolerance, we took what normally takes 2 to 3 technicians, 2 to 3 days, and we completed it with 1 technician in 2.5 hours. Now that's a 93% touch labor reduction. And the skeptics came back and said, we don't believe you. Those numbers there's got to be something else to this story. We kind of said, join the club. We're not sure we believe it. So we ran it over and over at different sites, at different locations with different groups of people. We're now up to 4 sites, 4 different groups of technicians and people with multiple activities, and we're seeing numbers like this. The second one, the one in the middle, is at Denver. This was a 91% touch labor reduction where we took an 8-hour activity down to 45 minutes. Today, when we run this activity, we can get it down to 15 minutes, so it's even better. The last one is at Kennedy Space Center, where we crawl inside Orion and place the locations for the fasteners inside the Orion spacecraft. This one we took from an 8-shift activity down to 6 hours. And you notice across the bottom, it doesn't take long to build. That's another question that we get. We were very cautious in which use cases we started with, so that it would be a good experience for the developer, for the technician, for the ME, who's typically building the content. It's important to understand what the end users are needing and to focus on that. And end users being both the technician or the person performing the activity and the person who is building the content. Both are very, very, very important. So in terms of fasteners, we can talk ROI data. I considered throwing up a very detailed ROI analysis here, but it's really much simpler than that at the highest level. We're saving about $38 per fastener. Orion has 60,000 fasteners. Lockheed purchases over 2 million fasteners per year. So you can see how the numbers add up pretty quickly. I'll also say that this use case applies not only to fasteners, it applies to strain gauges, to heaters, to thermistors, to Velcro. We use a lot of Velcro on spacecraft. To tape, to about anything that you're placing at a half-inch tolerance. So it's good to keep in mind the scenarios where you want to feel like this, Thor with the hammer. And the way that you do this is you have a network. You have a network of people within your company and a network of people, allies in the tech industry, tech partners, who you can sit and brainstorm with and figure out solutions and make things happen. Now, this was in the early days. We started off with step-based work instruction, and we saw significant numbers here too. You'll notice at the bottom on the left, there's also an 85% reduction in ramp-up time. One of the things that we're seeing is that it's important to measure, it's important to know what to measure, but what we're really seeing in terms of optimizations is what we call information overhead. It's the time to information. It's not how fast you can turn a wrench. It's how fast you can get to the point where you turn the wrench. It's the decision logic. So what we did was we chose the Air Force's OODA loop. You'll see here the bottom black columns are the action. Everything above that is the decision process, observe, orient, decide. The Air Force uses the OODA loop for optimizations. You'll also see the OODA loop used for car manufacturing. If you look it up, there's a recent article where they're using the OODA loop for the NFL in decision logic. But it really applies to the way that AR influences our workflow. We can map out each one of those processes in the decision logic chain. So this is what it looks like in its original state. Okay, and this is what it looks like in a simple form. Now, if you look across your industry and start to look at where you can plug in AR to optimize decision logic, it turns from something like this into more of a fractal, because you're plugging in that decision logic into areas that feed on themselves and cause the decision logic to change in other places. So it gets very interesting when you can map where all this influences your workflow across a full life cycle. So I'll, in the very near future, likely have more on OODA fractals versus just OODA loops. Okay? I'm a mathematician, so this is my happy place in fractals. I'll probably end on this slide and just go straight to questions. So this is another thing that I'm a firm believer in, that the art of the possible becomes reality when our persistence and determination exceed our dreams. I'd like to thank this industry for helping with this. It's an exciting space. So now I'll open it for questions. Looks like we have a few minutes. Any questions? Everybody's ready for a break after lunch. And I'll be honest, I can't see all of the hands, so.
Sure, I'm Paul Boris with Pramo. How you doing?
Paul. Good.
So, can you talk a little bit about the human interaction, like how you get people to kind of ingest these technologies and start to use them? You're doing all kind of incredible things in your operation, so people are used to technology. But is there fear of the technology, fear of it taking jobs? How do you kind of smooth some of those things over, and what happens?
Sure. So that's a very good question. How do you get people to be willing to receive the technology in the early stages? And this is something that we focused on. We heard from the industry that there was a challenge with culture, that people were afraid of using the technology, they were skeptical of using the technology, and we focused on how to resolve that. It's important to listen to your end users at the start and to ask them what their challenges are, regardless of whether you're looking at AR or some other solution. We brought in a group of technicians and engineers and spent a day looking at what we called tedious tasks. And we started to map out those tedious tasks and to look for the appropriate solution for those tedious tasks, instead of going to them and saying, we have AR, what can we do with it? So you want to find what the challenges are and see if they're interested in possibly using this technology to solve that challenge. When we took that approach, and we were very honest with them in letting them know that we really wanted their feedback. If they thought it was not the right solution, we wanted them to be very open with us in voicing that, and to get their inputs on what we needed to change for them to enable them. When they saw that they were a part of that solution, they became excited. And when they gave us feedback, we have tech partners who help us shape the technology to their feedback, and we do it quickly. So they see that they're shaping the technology that they'll be using in the very near future. And that creates an alliance that works very well. Another thing is when you have skeptics. I think of skeptics as being passive as skeptics and aggressive skeptics. A passive skeptic doesn't think that you can do what you say you're going to do, but they stand back and watch. And you want to keep them in that state where they're just watching. If you push them too hard, they become aggressive skeptics. And then they'll start telling you all the reasons that they don't want to use the technology. They don't like the form factor. They don't think it'll ever work. You can't connect to the system. And they'll start listing reasons and aggressively back their reasons. Now you have to flip the aggressive skeptic. And once they've voiced all of these different elements, it's much more difficult to flip them than if they're just standing back watching. So usually when we have skeptics, we let them be skeptical, and we find other allies. We run activities. They see what we're doing, and then they usually want to participate, or they want that technology for their program. Yes.
Oh, hey. My name is Paul Schlosser. I'm a PhD student at the University of Queensland.
Nice.
And so you have identified use cases where you could benefit quite a lot from augmented reality. And I was wondering whether you could talk a bit about how you identified those use cases and what you can do to find tasks that can be supported by AI, and where does it make most sense?
That's a good question. Where does it make the most sense to use AR, and how do we identify the use cases? We really listen to the end users, so we want to find out where they're challenged and what we may be able to do to help them. When we go back to the decision logic, when you have to spend time figuring something out, or when you have to take your, what I call rectangles of data, the traditional data sources, whether it's paper or whether it's a 2D screen representing that data, when you have to mentally map that content to something in the room, that's a fantastic opportunity to optimize. There's many, many cases where we don't realize how much time we spend interpreting data that we get in a rectangular format. And we can optimize that approach when we pop it out into 3D space and overlay content. Also areas where you see collaboration, better collaboration tools that are needed, where people have to show up in person. There's definitely opportunities there. In the past, we would try to use phone and video, but it didn't quite cut it for many of the use cases. And we still had people traveling to be on site or having to take time to be on location. Those are fantastic opportunities for AR and collaborative scenarios. But for use cases across, say, production environment, you really want to focus on the time to interpret data. Okay.
Hi, Cody Beebe with General Dynamics.
Nice.
You mentioned earlier that not all of your experiments, your prototypes, your ventures into AR, VR went well, right? There's a lot of failures. How did you keep those failures from demotivating your leadership, and what did you do to stance yourself for that?
I wouldn't exactly phrase it as failures. There were areas where we had skeptical interest. And notice I say skeptical interest. They're still interested, but they're skeptical. There's areas where you have a strategy, and things may go crossways and different directions. Your strategy may change. The way that you maintain interest is through value. And you start off at the very early stages expressing what can be done. Now, once you do that, you have to be ready, because once you show the value, like when you see a 90% number, you better be ready, because you're going to have a lot of groups really interested really quickly to have it now. And that can create another challenge that can be just as hard to keep it afloat as the opposite. Yeah. But it's a good problem to have when you have that type of interest. Okay. Thank you.